I've got, well, how is the shrimp, this shrimp has lived in here for 16 years. 16 years, I've never fed this pet. So then you go, well, how is this possible? Well, it's eating the algae that's growing in there. Well, how's the algae growing? Well, there's sunlight providing energy and it's taking CO2 out of the water and making photosynthesis. Well, what about the shrimp poop? Doesn't it just accumulate at the bottom and really get gross? Oh, there's some bacteria in there degrading the poop back to CO2, which the algae takes up, that the shrimp eats and lives. Oh, it's a completely enclosed system. It's sustainable until the shrimp dies. I've never seen them reproduce because I don't know if the mood is right in there. 16 years of sustainability. What are the rules? Well, don't put it in direct sunlight because it might get too hot from greenhouse warming. Sunlight goes through the glass, the infrared doesn't come out, and it could get really hot and it might kill the shrimp, right? Don't let it freeze or get too cold or similar thing the shrimp can't handle. But between something like 60 and 80 degrees, there's a perfectly adaptable system. In the winter, the algae grows less. In the summer, the algae grows more. There's some variability, but ultimately it survives. And the question now is, as we're changing the fundamental energy system, the temperature within this, are we reaching the threshold of the shrimp or the human or the elephant or the grassland or the whatever in the climate system? So a very good simple way of doing this. You can still buy these on Amazon. It's a little thing here. And you could sort of take a look. Really good to talk about sustainability and sort of systems. So we did some very simple things about some really, really complex systems, but what are the impacts and how do you talk about them without getting really depressed? But you have to know about some of these things. How much time do I have, Jim?
About 5 minutes.
So I won't be able to show all of the things, but there's temperature increase, there's melting of glaciers and ocean thermal expansion that leads to sea level rise. We talked about increased hurricanes and storms, droughts, fires, etc. Here are the $31 billion weather and climate disasters of 2024. So this is one way of this is a lot of money. It turns out that if we do the mitigation now, we save 6 times the disaster relief. So if you did the work now and spent the money now, you save 6 times the money. There's just a Nature paper that just came out. That's not counting the suffering and human life loss. That's just the money. So you can think about that. And these are all directly related to climate change. The temperature is fundamentally different than it was 100 years ago, and that drives a lot of these things. That's one way of sort of communicating. Another one is this Bloomberg thing. What's really warming? Is it going to work? Yeah. Here is the temperature record, then in black, of it increasing over time. Is it changes in the Earth's orbital system? Well, we know what that is. Is it the sun? Sunspot cycles, all this. We know what that is. There's some uncertainties around each of these. Is it, okay, I got to show it a little better. No? Sorry. I'll just go with it. Is it volcanoes? We know they can cool with dust clouds and whatnot. Is it all 3 of these natural things combined? If you add them up, no, it doesn't look really like the temperature record. Is it deforestation? And that one actually cools a little bit. Is it ozone pollution in urban cities? No. Is it aerosol pollution? Cools. Sorry for the graphic here. Is it greenhouse gases? Well, greenhouse gases would actually lead to a larger temperature change than all of those things together. If you add those things together, all the natural and human causes, to the eye, pretty good predictor. Do we know the complex system? I think we do. And this is 10 years ago. Okay. So, I'll show, if I have time at the end, I might show this, but here's a video with a very dramatic sound to glacier calving in the Arctic. And that's another way of sort of demonstrating the impact and feeling the emotion of it. We'll see if we have time. Ocean acidification, you can look at the shells under a microscope and see them dissolve, basically. CO2 is going up, and we know the chemistry that the ocean PCO2 is going up, and therefore pH is going down, because that's what pH is, a measure of acidity, lower pH. So let's spend a couple minutes on hope and some solutions that are coming from people that the students will be and are now. There is an Earthshot Prize. I was wondering if you guys went from South Africa. That was just there in South Africa this year. This is just conservation of energy. Well, I feel like there's a lot of waste heat in industry. We melt metal, we make cars, we do these things, and then the heat is like just exuding out of the factory. That's energy that shouldn't be wasted. Can we convert that to something useful? And we go, well, useful energy is gasoline and electricity, and unuseful energy is heat. So these guys have said, well, that's just a really simple idea. Let's work really hard on the electrochemistry to try to convert the heat energy back into electrical energy. And they have a solution, and they won £1 million to continue sort of that operation. We have a Northeast Earthshot Innovation Prize that we've spun off of the Earthshot Prize since it was here 2 years ago in Boston. It was the second place Prince William came. We were part of the Earthshot Prize here in Boston because Boston is a green leader, a green city leader in the world, and Massachusetts is a leader state in the world. The mayor and the governor were taken by the chancellor of UMass Boston to the Vatican to talk about climate change and solutions at the city and state level. Another person, this person just came out of college, was during COVID couldn't charge her car. So she was buying a car and she says, I can't buy an EV because there's no chargers, it's 15 miles away. So she spurred the idea of, I want to put some kind of a cheaper, better business model charger in the city so that people can allow people to buy electric vehicles and be part of the solution. The Mayor Wu said, this is great. I want to have one of these chargers within a 5-minute walk of every citizen of Boston. And the way that this model works is it's relatively cheap. It plugs into the building's electrical panel. You have extra capacity in your building. The building owner pays for the original installation of this thing. The electricity comes from the building, and the building gets money, some of the revenue share from the charging of the people that charge their cars there. And they can make $1,000 a year from each charger that they install. So this is happening in Boston. Simple idea that your students can come up with that is actually becoming a reality, and we can sort of look at those models. I'm going to cheat a little bit on my timing, but we'll see how this one goes. This is a model where NetLogo, you can watch greenhouse warming. These are sunlight rays coming in, and the yellow ones are reflecting off a white surface of Earth. Albedo is high, ice, snow, white surfaces. But if it's black and dark, the albedo is low, and it is absorbed and turns into infrared photons, heat that is trapped within the Earth's soil and surface. And eventually some of these hot Earth re-emits to space. So the energy balance has to be, the amount of energy that comes in as visible has to be the same as the amount that goes out as visible and infrared. But if we add CO2, we find that the outgoing infrared photons can be trapped and re-radiated in all directions, including back down to Earth, acting as a heat-trapping blanket that then increases the emergent indicator, the temperature of the system. That's global warming. We also know that if we add clouds, that increases the albedo and it can reflect and cool the Earth. And that's some of the geoengineering. Let's increase the clouds or the reflectivity with silver particles, and we can see that it cools the Earth. So you can play with this very simple model to understand greenhouse warming and think about solutions in different ways. This model is incredible. It's called En-ROADS, E-N-ROADS, and you can just look it up. MIT sort of invented it. It is available online. You just go to this thing, you say explore. It says it was updated yesterday with the most recent peer-reviewed articles. It's got thousands and thousands of peer-reviewed articles. It's all that complex model information in that model stuck into this, which says, Here are all of the sources of energy, including coal, oil, and natural gas being the dominant one. Renewables is growing here in green from 2000 to 2100. And here's the emergent indicator, 3.3 degrees of warming. Paris Agreement said 1.5. Scientists are praying for 2. It doesn't look like we're getting anywhere near that. And what do we have to do to lower the current 3.3 trajectory? Well, let's think about increasing renewables dramatically. Let's think about increasing energy efficiency dramatically. Let's electrify the entire grid. Let's think about carbon sequestration. All of these are solutions that your students can work on and find a project about. I did all of these things. Carbon tax, woo, big one. Fantastic. I'm going to reduce my natural gas. I'm going to reduce my coal by a lot. Globally, still at 2.4 degrees. The idea is that we need everything and everyone, and ideas that we haven't even thought about. Students working on all of these ideas, so there's some entry point in there. But all of these things, and some stuff that's not even in here. So that's sort of the hopeful piece. We need everyone, we need everyone's perspectives, ideas, brilliance, and hopefully we can sort of get there together somewhere. We've taken what's a natural carbon system, tweaked by the red lines, and we can sort of enter into this very complex system in very simple ways. And I'm hoping that your students come up with some of the ideas that in 2 years are some of the solutions that are actually going to be implemented. So in summary, climate is changing, climate is changing now, right now, and there are indicators all over your neighborhood and all over Massachusetts and all over the world that your students can play with, discover, plot, communicate, think about, enhance. The big ideas, conservation of mass, systems, conservation of energy, are fundamental to the state frameworks, the NGSS standards, and learning throughout their lives. These are the 8 big key concepts I teach in my 500-person undergraduate class. They're easily applied to climate change and make climate change much simpler than the complex system that could be overwhelming. Simple examples and activities are accessible right now to you and your students, and I've given you just a couple of them. You're going to get more in the workshops and sort of all that stuff. And a focus on hope rather than climate anxiety, about innovation, inclusivity. Can we include the other half of the world that we've left out in the Industrial Revolution as we transition, the green transition to renewables? That's a really exciting win-win proposition. We can solve climate change and solve social inequities across the world. And imagination, creativity, we do a lot with hope and art. And this is a poster that says, pretty simply, here's a wind turbine, here's a plugged-in car, here's a green, happy place. We can change, we can do this. It's a hopeful message. So I'll stop there and hopefully we'll have time for a couple questions.
Excellent job. You even highlighted some of the organizations that are going to be here. Are there any questions for Dr. Chen? Pick his brain now.
I'll play this in the background while you're...
I loved so many of the graphics and the data that was shared. I wonder if we might be able to have access to it.
Absolutely. I'll share this with Jim, and Jim can share it with you. Yeah.
Yep.
Thank you.
Awesome. In the back? What? Oh, sorry. Go ahead, Rich.
What's your inspiration? What led you to this particular path in your life?
My mother is an artist, my father is a scientist, and they're both educators, lifelong educators. So I've always been engaged in teaching and learning. My students are the inspiration. They come up with, they surprise you every day with their thoughts, their talents, their skills. We have the 3rd most diverse population in the country at UMass Boston, and you don't expect things that are coming from their life experiences. It's incredible. And we need to, hear them first, allow them to succeed, and then we will solve this really existential crisis.
Thank you.
I've been doing the cool science competition with my students. This is my 4th year. I teach 6th
try to make it a little, I'll calm, yeah, go.
It's a great, engaging, I actually just kicked it off this week with them. We just started the competition.
Awesome.
We're breaking it down, and they absolutely love it. It's been great. So the resources you shared just in this are, I'm like, oh, I keep, like, I'm writing it all down because I'll be implementing it like next week. So.
I tell a bunch of stories, but one of them is there was a beautiful hand turning off a light switch to conserve energy as part of the solution. And she won, and I said, that's an amazing, it's really hard to draw a hand. I said, that's an amazing hand. How did you learn to draw that? She said, oh, I've always been a hand drawing expert. So now we have an entree for a hand drawing expert into climate change. She was never interested in climate change, but now because she was engaged in this contest, she is thinking about things that she wasn't thinking about. Bringing your skills, you know, there's a lot of jobs, there's 50,000 climate jobs coming in the next 7 years in Massachusetts. So these are high-paying jobs. I can't believe how much electricians make. And they go, well, what jobs are climate jobs? And then as I thought about it, I said, every job is a climate job. Because if you're not aware of the opportunities with the shifting world, the shifting local environment, the shifting economy, then you're missing out and you're losing an opportunity. So you really need to learn a little bit about climate change and the opportunities in the system to be able to engage whatever work in healthcare, in law, in economics, in business, in environmental science, whatever it happens to be, as part of this. This is a chasing ice. They've seen this huge thing the size of New York fall. It's very loud. I can, but it's another way. Oh boy. Why not? I don't know. You can hear it. I think if I exit. So it's, you know, the size of New York falling into the ocean, very loud. They just happen to be there. I mean, they were looking for it, but then they go, whoa, what's happening? And it happens fast. It's happening episodically. It's not a gradual thing. It's a dramatic thing. And it's another way of communicating the impact of, oh, I hear and see and feel it, and I remember that, as opposed to like the data or the graph or whatever. So.
The cabin faces 3.
Oh, boy. All right.
Well, thank you. Okay. So we're going to start transitioning now. If Max IQ and Globe and Resource Modeling Association and Climate Interactive want to head to their spots and start getting ready, I will transition and give everybody kind of the map of where they're going. I just got to